Hello everyone. Today I will talk about experiences my colleagues and I have had in developing an inline zone tillage tool, a conservation planter, and a residue conserving cultivator in the West African country of Burkina Faso. I will focus on the impact of the planter on smallholder women farmers. I will discuss the USAID-supported Appropriate Scale Mechanization Consortium and the priorities we set in collaboration with the local farmers, women's labor expectations and our cropping systems approach to mechanized innovations, long-term sustainability, and improving smallholder farmers' lives, as well as the importance of gender sensitivity and awareness in developing mechanization and linking innovations with social processes. A few facts about Burkina Faso. More than 80% of the people are involved in agriculture. Nearly one-half of the farms are less than 2.5 hectares in size, and a 10-hectare farm is a large farm. Most of the rural population lives in poverty and relies on subsistence farming. One-half of the farms have a cash income of less than $3 per day. The primary cash crops in the Haut-Bessin region, where we are working, are maize, soybean, cotton, peanut, and sesame. Nearly 70% of all field work is by hand. About 29% is with draft animals and less than 1% with wheeled tractors. Farmers with oxen are privileged farmers. Even where tillage is with animal power, nearly all planting, weeding, and harvest is by hand. At the outset of the project, we worked in close collaboration with farmers, in-country researchers, government agencies, NGOs, service providers, and other stakeholders to identify the top priorities for local innovation. The top priorities for innovation were tillage and land preparation, planting, and weed control. These are exhausting, time-consuming tasks, typically relegated to women and children. Life is difficult for smallholder women farmers in many developing countries. They bear responsibility for cooking, child rearing, fetching water and firewood, hand planting and weeding, and additional off-farm work to supplement the family income. These activities often span 16 hours per day. Traditionally, women and children hand plant maize using a short-handled hoe known as a daba, by bending over and placing 2 seeds every 16 inches. 2 seeds per furrow opening assures germination of at least one plant and few skips within the row. This is tedious work, and many women reported aching back from hours of stooped labor. In addition to household chores and farm work, women contribute to family income through off-farm activities such as harvesting and processing shea butter and cashews for sale. Planting responsibilities conflict with these activities, making it difficult for them to attend the weekly village market to sell goods and purchase supplies. Women face many demands for their time and attention at planting. They have to hire and manage a planting crew of 15 to 20 people. In addition to managing the workforce, they have to provide meals for them. This further increases their overall workload and cost. Managing the planting crew can be stressful. The crew's work can be of low quality with inconsistent seed spacing and variable seed depth, each of which diminishes plant population, yield potential, and may require replanting. Planting crews are costly, about $35 per day for a team of 20, to plant about 1 hectare per day. Household conflicts sometimes arise from expectations for the women to be both in the field and have family meals ready on time. Our work's scope encompassed the conservation cropping system, an inline ripper to reduce tillage intensity, improve water infiltration, and conserve protective crop residues, a planter to reduce the drudgery of hand planting, and an animal-drawn skim tillage cultivator to improve weed control. We avoided importing technologies in order to support and build the skills of local artisans and blacksmiths. In adaptive management, this approach ensures that women have a voice in designing and adapting future innovations in mechanization. In the process of on-farm testing, we considered reasons for potential technology failure, including high cost, poor performance, and a lack of timely availability of parts and repairs. By building the local artisans and blacksmiths' capacity, we guaranteed that farmers have local access to skilled and cost-effective labor for repair and maintenance. The planter placed the seeds at a uniform depth and spacing. That ensured that seeds germinated faster and at a consistent rate. The mechanical advantage of the planter enabled a biological advantage of the maize crop. On-farm comparisons showed that using the planter increased grain yield by 50 to 150% compared to hand planting. Post-planting bird predation is a major source of seed loss with hand planting. With machine planting, the birds did not steal the planted seeds because they could not find them. The planter reduced the need to plant twice, which was often required when planting by hand because of seed loss and low germination rates. In meeting with both men and women farmers after 1 to 2 seasons of use, a group of women recounted the time and labor savings impact of the planter on their lives. They noted that a family of 3 with the team of oxen could accomplish the work of a hand planting crew of 15 to 20 laborers. One of the women said, "Here, women and children do the planting. I work with the planter, and it was very easy to use. With the planter, it is much faster." Most women are involved in off-farm entrepreneurial activities to contribute to the family income. The women use the time saved with the planter to accomplish other domestic tasks, such as cooking, fetching water, childcare, and going to the market. They could divert time from subsistence farming and household chores to income-generating activities such as processing shea butter or cashew nuts. Income from their off-farm enterprise funded the children's schooling, food, and clothing. Also, they saved money for unexpected expenses such as medical care and other family emergencies. The planter influenced labor division within the household by making planting a shared household task rather than a woman-only task. Access to and use of oxen to operate the planter is generally a gender barrier, whereby women preferred not to handle oxen, considering it too dangerous. Farmers overcame this barrier by women running the planter and men driving the oxen. Our work in Burkina Faso highlights the importance of including women in the design and adaptation process. Technically efficient innovations are rejected if they do not meet the specific needs of the users. Women had difficulty turning the planter at the end of the cropping rows, so we lowered the height of the planter's handles to facilitate turning. They also requested seed plate modifications to enable planting additional crops, such as cowpea, groundnuts, soybean, and sorghum. Our work demonstrates that technical solutions are most likely to be successful when linked to the social processes that give rise to them, and by using a participatory approach involving men and women, farmers, local fabricators, and others. In the case of the planter, Design benefits included efficient and effective planting with increased grain yield. Process benefits included accessibility, affordability, and repairability. Gender benefits had time and labor saving for women farmers. It is essential to evaluate mechanized innovations in technical terms and social, cultural, and economic contexts. Involve women in devising and testing designs to ensure that they reach, benefit, and empower female smallholder farmers. In Burkina Faso, women saved time and labor, which they re-employed in domestic and income-generating activities and invested back into the household. Innovations in appropriate scale mechanization improved the lives of smallholder women farmers in Burkina Faso. As a group of women farmers exclaimed to the team, "God will thank you for what you have done for us. Please do not forget about the women. Now we can breathe." The Appropriate Scale Mechanization Consortium is a collaborative effort among various researchers, farmers, agribusiness, and other stakeholders. Funded by the United States Agency for International Development, the ASMC works hand in hand with smallholder farmers in developing countries to improve their quality of life while advancing the farming system to sustain the natural resource base.